Okay, so the next thing we're talking about is the fundamental accounting principles. So this is chapter 4 notes. It's the bottom of the, not the last 2 pages. So here's the last page, right? Everyone hold up the last page. And then flip backwards 1, and it's right here. Bottom of that page right there. Everybody on board? Counting chapter 4.4 to 4.5. That's where we're at. So, let's get a reader. Jacob, go ahead. Jacob, go ahead.
The total number of possible outcomes of a series of decisions found by multiplying the number of choices for each decision. Example, 2 pens, 3 shirts, 5 shoes, 4 socks. How many possible wardrobe combinations?
Good.
2 times 3 times 5 times 4 is possible.
Perfect. Right, so I'm trying to figure out what to wear. I've got 2 pairs of pants to pick from. And then I've got 3 shirts, I've got 5 shoes, 4 socks. For every decision you make, you multiply the number of choices for each decision to figure out how many total possible combinations there are. So you could think of this as the exact same thing if we did a tree, only with a lot less work than doing a tree diagram. And this would be the first layer of branches. 2 pants, right? And then from each of those you have second layer, 3 shirts off of each one of those. And it would go on and on from there. So let me show you just the basic first couple layers of tree, what it would look like here. Right, so I've got jeans or slacks. Once I pick something, then I pick a shirt. 3 options for the shirt. But there's 3 here or 3 here. So for my shirt I have a group of 3 choices. How many groups of 3 do I have? 2, 1 for each of my pants options. So that kind of makes sense. So now I have 6 possible wardrobe combinations. I have slacks, red, blue, green, jeans, red, blue, green. So I have 1, 2, 3, 4, 5, 6 possible wardrobe selections just off of those 2 pants and those 3 shirts. Because I have 2 choices here. Each of those 2 choices has 3 choices off of it. So 3 times 2. If I were to add in my shoes, I had 5 shoes. 1, 2, 3, 4, 5. So that'd be 5 different possibilities there. How many groups of 5 do I have? 6. 1 for each one of these. Everybody kind of understand what I'm saying? You put one of those on each one of these because there's 6 spots here. So 5 times 6, where did the 6 come from? Came from 3 times 2. So 2 times 3 times 5. That would get me to how many possible combinations there are with shoes, shirt, pants. So you guys try this. So just on a piece of paper, it's not in your notes, just try to sort out with your neighbor how many combinations you have with that. Take 30 seconds and go.
So we have 2 pants. Pants and pants. Wait, why?
What are you going to multiply?
So I'm like about to do it, but I'm only like shoes.
Oh, you were doing a whole tree.
I gotta practice with
I'm
4 days later.
Okay. How many options for pants?
2,
Shirts,
6,
shoes,
3,
socks.
5,
What are you going to do with those numbers?
and
You're going to AND them. Yeah, you're going to multiply them. Right? So you're going to have pants and shirt and shoes and socks. So you multiply those ones. You end up with 2 times 5 is 10. 3 times 6 is 18, so 180 options. On a test, when you're panicking and you're like, God, do I multiply or add? Just draw yourself a little tree with like 2 pants and like 3 or 4 shirts, right? And you can kind of count up and say, oh, 4 shirts, 2 pants. That's 8 options. How do I get from 4 and 2 to 8? Do I add? No. Multiply. Oh yeah, okay, it's multiply. So whenever you're on the test, try to find like a small, controllable way that you can kind of wrap your head about it and kind of test it out and see which one is the, I already told you guys that, didn't I, earlier today? And check that out. It's hard to remember everything. So if you can find different ways of trying to test out possible ways of doing it, that'd be better. All right, so why don't you guys do problem 5 on your lab? Take a couple minutes. All right, guys, take a look. Hold up for a minute. Let's take a look at this. What if it's a 2-digit PIN number? What's the largest two-digit number out there?
99.
99. What's the smallest? 00. So how many options are there? How many two-digit numbers are there? 100. 1 to 99 plus 00? 100. So that might give you some information on how you might attack, or, if you have a correct or wrong answer for part A. All right, you guys are in a lot of pain.
It's because she knows how to do the 2-digit ones.
Here's my phone. I need to pick a 3-digit security code. What's the first decision I make? 0 through 9. The first decision I make is going to be picking a number. So how many options are there for that first decision? 10. What's the second thing I do? Pick a second number. How many options for that? 10. So how many decisions am I making altogether? 3 choices. Everyone follow that? 3 digits, 3 choices. So everybody draw this. Draw 3 lines here if you didn't already. Little multiplications in between. How many options for your first one? 0 through 9, right? 1 through 9 plus 0, it's 10. Second one? Third one?
10.
So altogether you have 10 times 10 times 10? 1,000. Good? All right. Counting rule. Do you guys need a minute to check with the neighbors about it? Take 30 seconds if you want. Check with your neighbors, it's fine. Okay, on to counting rules. How about, Michael, go ahead and read.
Factorial is the product of all positive numbers from 1 to a number.
Go ahead.
N factorial equals n.
So n factorial, you start with n, it's go down all the way to you get to 1, multiplying them. Keep going.
N parentheses n
Oh, no,
minus.
that's okay, that's fine. So n factorial, you start with n, and you just keep going down 1 until you get to 1. So like 9, 8, 7, 6, 5, and just multiply all those numbers down to 1. 0 factorial, please note 0 factorial is 1. It's defined as 1. Just stop there and that's good. Keep going.
3 factorial equals 3 times 2 times 1 equals 6. Which is the number of ways to arrange 3 things?
Right? So 3 factorial, 3 times 2 times 1. Number of ways of arranging 3 things. Red, blue, white. I can arrange it 6 ways. How many options from, I can go red, white, blue, white, red, blue, red, or blue, red, white, red. So this tells you how many ways there are to arrange 3 things. Because if I have red, white, and blue, how many options for the first position? 3. Once I pick one of those in the first spot, how many options do I have left for the second spot? 2. And then for the last one, there's just that one left. 3, 2, 1. So this is the number of ways of arranging 3 items. Generally speaking, factorial, oh, sorry. Everybody find 4 factorial, go ahead. It's not on your sheet, I don't think. I think you have to do it separately. Just find it. What would you multiply? Talk to your neighbors about it, 15 seconds. If you're not talking about it, I'll probably call on you. Jacob, you ready? All right, Jacob, how do we do it? Jacob, how do you do it? 4 factorial? Okay, you can be Jacob, that's fine. 4 times 3 times 2 times 1. Right, so 4 factorial start with 4, multiply all the numbers down to 1. If I do that, 4 times 3 is 12, times 2 is 24, times 1 is 24, so that equals 24. That is the number of ways of arranging 4 items. Right, because you have 4 items. How many options for your first position? 4. 3 left, then 2 left, then 1 left. We can also look at this using a tree. Right, so if I want to pull a tree out here, maybe. Right, there's 4 choices for the first spot, and then after you do that, then you only have 3 choices left. After you pick one of those, and you only have 2 left, and then after you pick one of those, you only have 1 left. Horse race. Who's ever heard of a horse race?
Of a horse race?
Horse race. Okay, so say there's 8 horses in a race. Can any of them win? Right, makes sense? Any of them can win. So how many options are there for first place? 8. Any of them could win. After one comes in, how many options are there for second place?
7.
And how many options are there for third? 6. Perfect. So, so if we only care about the first 3 spots, then we're picking 3 spots. And we have how many options for the first spot?
8,
Second spot?
7,
And last spot?
6.
Everybody on board? This is a special case of the fundamental accounting principle called permutations. It's when you have, you're selecting from a pool of items and you cannot reuse items. So we have a pool of 8 horses. Once we grab a horse for a position, we can't use the same horse. You can't come in first and second. And order matters. So you have, it's arrangement of objects in a specific order, order matters. So you're picking a certain group from the same pool and you can't reuse them. The easiest way to think of it is just this way. So if I have, you can write it as P83 or 8P3. This means that this is how many items you have. This is how many items you're picking. So on your little formula sheet, when you'd write that down, I would write down the formula of NPR would be you have R spots that you're multiplying, and you're going to start with N and then count and then move and then count down from there. Count down 1 each time. So here I have 8 items. I have 3 spots. So I'm going to have 3 spots here that I'm going to multiply. I'm going to start with 8, and I'm going to go down 1 each time. 8, then 7, then 6. Does that make sense? There's a whole long complicated formula, but I don't think the formula makes sense intuitively, right? You should be able to figure it out just from logic. Memorizing formulas, that's like the worst thing in the world. Yeah.
Would
No.
you say N was? R is number of spots and...
And N is how many items you have, how many items you're choosing from. So R is the number of items you're picking, And N is how many choices you have. How many items you're choosing from, I should say. So what about this? What if we want to know the order of every single horse? So all 8 of them. I want to know the finish of every single horse. How many spots am I going to have out? 8. Oops, I have it over here. How many options for the first spot? Second spot? Third spot?
6,
Next?
5,
Next?
4,
Next?
3,
Next? Next? And then we're going to multiply them all. All right, everybody on board with that part? This is 8 items, picking 8. Right, if you pick all of them, that's, another way of looking at it is just how many ways can you arrange 8 items? We know this number, it's 8 factorial, we just found it, we looked at those earlier. So really, 8 factorial is just a special case of a permutation when you're picking all of them. Does that sort of make sense? You know, you can kind of look at it as just how many ways can I arrange order. They say order. When they say order, they really mean arrange. Arrange 8 horses. How many ways can you arrange 8 horses? I'm going to put you in the first spot, you in the second spot, you in the third spot. You know, you can kind of move them around. Here's another example. Let's get a reader for this one. How about Vanessa? Vanessa F.
A radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guest is important. How many different ways can this be? And it's-
Great. So how many people we're picking? How many spots do we have?
3 spots.
3 spots. So everybody should write down, do you have this on your notes or not? No? Okay, this is how you should do it, if you're doing it. 3 spots. Put in your 3 spots. And then, what's your starting number? 6. So 6, and then just go down. 6, 5, 4. And so it ends up being 6 times 5 times 4. They would also call this 6 picking 3 of them. You have 6 items, you're picking 3 of them. Here your N is 6, and your R is 3. Because you have N is 6, R is 3. Make sense? Okay. Cool. So here, this is how I do it. So this is my idea of permutations. You start with 6, and you go down 3 spots. So 6P3, start with 6, P3, picking 3 spots. Straightforward, super easy, really clean. I would say do not use the help buttons on Connect Math are often good for other chapters, but I would not use them for this section, not for 4.4 and 4.5. Don't use them for that one. It's confusing.
Yeah, it has you subtract 1 on the
Yeah,
top,
it's
subtract 1 on the bottom.
It just, yeah, it's more, because you have to massage the numbers to make them work into a formula. Just have your formula be, start with N and count down and multiply down R spots. That's literally what I would have you guys put in your thing. So start with N and, there we go, and multiply, I would say multiply down 3 spots. So start with, and maybe we'll say N, we'll put that down, R spots. That's kind of what I use for the formula, yeah, I just, okay. All right, so you guys do problem number 7 on your lab